Okay, we're going to talk about multiple oxidation states. So an oxidation number is basically the charge. And so there are quite a few elements, or metals specifically, who have multiple oxidation numbers. For example, like copper is sometimes a +1 and sometimes it's +2. And so there are certain rules we have to go through. Metals and so here's the rule. Metals in group 1, 2, and 3, zinc and silver, all have one oxidation number, so that should be numbered. And so let me just change these to number. And so that means we always know what their oxidation number is. So let me just give you an example. So, for example, the oxidation number in group 1 is always +1. Group 2 is always +2. Group 3 is always +3. But what about these transition metals, the D block? What is their oxidation numbers? And so it gets a little tricky there. And it's not something you memorize, it's something we actually can figure out by looking at the ionic compound. But you just have to know, if you remember, these all have one oxidation number. So zinc is going to be a +2 and silver is a +1. Everything else, all the metals, now you gotta be careful because I'm saying all the metals. So everything here, let me do a different color. The whole D block, most of them have multiple oxidation numbers. And all the metals. So these are metalloids, right? So these all have oxidation numbers, multiple oxidation numbers. So these are your metalloids, right? So they don't count. They're fine. But all your metals have different oxidation numbers that are circled in red. All right. So we kind of encounter the problem where, okay, now some have multiple oxidation numbers. How do we show that the multiple oxidation numbers, or which oxidation number they have? And then how do we determine that as well? The second thing is, if a particular metal has multiple oxidation numbers, we actually write the oxidation number, or the charge, by putting it as a Roman numeral in parentheses. So let me just give you an example. So if I write copper is a common example that has multiple oxidation numbers. So an example could be like copper 1 sulfate, or let's say sulfide. So we know this is copper. We know this is sulfur. This is sulfur. Copper 1 just means it's +1. We know sulfur is -2, and so you need 2 coppers. So it's copper 2 sulfide. Okay, so it just tells you, like, so the Roman numeral tells you what is what. Okay. All right. The Roman numeral tells you the oxidation number. I'm going to skip this and come back to it, okay? I'm going to just go to the naming part. So what is the formula for iron 2 nitride? So iron 2 is, the 2 means it's a +2 charge, the oxidation. So it's going to be Fe +2. Nitride is N-3, right? Nitride is N with nitrogen has 5 valence electrons, so that's going to be N-3, right? To -3, so it's more negative, so I need Fe +2, Fe, N-3, so that's this. Right now I have +4 and I have -6, right? So I need one more, so it'd be Fe3 and 2. Okay. The next one is copper 1 sulfide. Oh, we did this one, but let me just talk about it again. So copper 1 sulfide. So remember, copper is Cu +1. How do we know it's +1? Because it gives you the Roman numeral. Sulfide. Sulfur has 6 valence electrons. So it's going to be S -2 and wants 2 more. So S minus 2. All right, are these neutral? Nope. What do we need to do? Oh, it's 2 negative, so I'm going to add an extra positive. And so this will be Cu2S. And we did this one. Okay. All right. The harder part, though, is I'm going to go back now. This. We have to. So, how would you name copper? Copper fluoride, or the CuF? Well, in order to do this, we have to determine the oxidation number of copper, and so remember, a ionic compound is made up between copper, or a metal, and a nonmetal. Fluorine is your nonmetal. Fluorine always has one oxidation state. So your nonmetal or your anion always usually has one oxidation state. What is that oxidation state of the charge? Well, fluorine has 7 valence electrons, so the fluorine is always going to be F minus 1. So above here, I'm just going to put a negative 1, right? Okay. And then copper, therefore, is going to be, so I have F minus 1. And then so now I have copper is going to be what? However, we know that copper, there's only one copper. So in order to balance out the negative 1, this single copper has to be a positive 1, right? So let's name it now. So now this is called copper 1 fluoride. Why did I put a 1? Not because there's only one copper, but because the oxidation number is a positive 1, right? And so that's why the Roman numeral is 1. Let's take a look at lead. This Pb, this is lead and oxygen. All right. So oxygen, we always want to figure out, okay, what's the charge on oxygen? So oxygen has 6 electrons, so it's always going to be O minus 2. All right, so to put lead and oxygen together, we know there's one lead and there's 2 oxygens, right? Because of the subscript. So if you look here, in order to put this compound together, for every 1 lead, there's 2 oxygens. So this total side is going to be negative 4. Since I only have 1 lead has to be a positive 4, right? And so this is going to be lead 4 oxide. Let's take a look at this. This is mercury and this is oxygen. Now, one thing I should mention, I'll do it on this one. The first thing I want to do is, so I look at oxygen. I first find mercury. Now, mercury, I notice, is not in group 1, 2, or 3. It's not silver or zinc. So I know it's going to have multiple oxidation numbers. So immediately I think, okay, we are doing we have to use Roman numerals, right? And so that's something you always want to check, because if I give you an example where it's aluminum or it's something in group 1, 2, or 3, there's no need for a Roman numeral because they all have one oxidation number. The reason why we need Roman numerals is because they have multiple oxidation numbers. You need to know which one, which type of lead you're working with. There's lead 4 and there's also lead 2. All right, let's take a look at this oxygen. So we know oxygen from before is a negative 2, so O minus 2. There's going to be 1 mercury. Right, so that has to be a plus 2. So it's going to be mercury 2 oxide. Okay, so always check. So for example, if I gave you, I want you to name aluminum chloride, right? So name this. The first thing I'm going to do is I'm going to check my metal. Aluminum, is that one of the ones I need a Roman numeral? Is it found in the D block, or is it found in group 4 in the metals? And then if the answer is no, then I won't. Then I don't have to do this part, right? All I have to do is write aluminum chloride.
Are you? Maybe.
If it's do I need a Roman numeral there? No, I don't. Why? Because aluminum is in group 3. Group 3s all have one oxidation number. So you got to be careful. You always want to check when you're naming these. Here is the homework. So the homework's good. I'm going to open it up. I want you to do some of these binary ionic compound stuff, so the stuff up here. But the big test is when I mix the practice. So some of them require Roman numerals and some of them do not. So you're going to have to be able to distinguish between both. So make sure you do both sets of problems.